In this video, we're going to look at the auto-wired annotation in Spring and see how object instantiation works. First of all, this is a good example of polymorphism, something I've mentioned several times before. Remember what polymorphism means. First of all, it's one of the four principles of object-oriented programming, the others being abstraction, encapsulation, and inheritance. What polymorphism means is that the variable type and the object type can be two different types. So the variable type can be an interface, and the object type can be a class that implements that interface. That comes in really handy with Spring, because what we can do is we can make a variable of this interface type and then put the auto-wired annotation on top of it. And then we can make classes that implement that interface and put the @component annotation on top of them. And then Spring will automatically do the object instantiation that we used to have to do ourselves. In other words, take a look at this bottom line here. If you see I plant DAO, if you just stop there, that's declaring a variable. Declaring a variable is like paving a parking space. You're making it available, but you're not putting anything in there. The variable type is the interface I plant DAO, while the variable name is plant DAO. Now, let's continue. If we see the equal sign, we know that's the assignment operator. Let's look on the right side of the equal sign. There you see new plant DAO stub, open and close paren, terminate with the semicolon, and that is creating an object. The equal sign is taking that object and assigning it to this variable. In other words, an assignment means that we have a parking space and we're putting a car in it. In this line, we're doing both of those things. We're paving the space, we're making the car, and then we're putting the car into the space. The very first time we put a car into that space, it's not only an assignment, but it's a special kind of assignment called an initialization. In Spring, we typically will do the declaration, and we'll let annotations handle the object instantiation and assignment. There are several annotations that we want to consider in Spring. First, auto-wired. That means find an object that matches this variable. Qualifier. We might have multiple matches, so if we want, we can qualify one match and say, this is the one that's the highest priority. Now, component. That's what we put above a class that we want to be instantiated. There are a couple of annotations that are extensions of component. They're essentially like component, but they just add additional information. And that's service and repository. Service is what we tend to put above a service class or a business logic class. And repository is what we put above a DAO. Very similar to component, it's just helping us to mentally identify the purpose of these classes and add some other value add as well. Now, component scan is something that was first introduced in old school application context Spring and is now available in Spring Boot. And what that means is, let's just look for matches between auto-wired and component or auto-wired and service, auto-wired and repository, any of those. And then Spring Boot application is kind of a catch-all annotation that says, give me all kinds of Spring Boot goodness, including component scan. Let's take a look at our application class, and if I mouse over Spring Boot application, you're able to see several annotations that are essentially included in the Spring Boot application, including component scan, as you see down below. So our goal for this lesson is to take our controller and match that up to iSpecimen service by using auto-wired, then annotate our stub so that it can be instantiated and saved into this variable of type iSpecimen service. Now on the DAO, we want to do something similar. We want the specimen service stub or the specimen service to talk to an interface called iSpecimen DAO. We will have that auto-wired, and then we will create a new class called Specimen Dao Stub, and we will put a repository annotation on top of that. After that, we'll jump right in and we'll debug and make sure everything works together. So let's start with the controller. And if we take a look at the controller, we don't have a whole lot of attributes defined just yet. So let's go ahead and define iSpecimen service and variable name specimen service, and then Alt-Enter to bring in this import. And now let's add the auto-wired annotation above it, just like so. Now the neat thing is that's all we need to do, and if we come in and take a look at our endpoints, we can start to map some of these endpoints. So take a look at the post mapping. We know this is creating a specimen, Right now it just has one line, but we can add a few more lines to it. Let's say specimen service dot save. Remember, we made that save method when we were working through our test-driven design. Now we can pass in the specimen object, and we know that it is going to return to us a specimen object. So let's say specimen new specimen equals specimen service.save, and then we can simply return new specimen. Now, it's giving us a red line because there's a try-catch here. So let's Alt-Enter. We could add the exception, or the other thing that we could do is simply catch the exception if it occurs. That'll take a couple more lines. I'll go ahead and do that because that will give me an opportunity to add some logging a little bit later. So we split the declaration and assignment, and then we simply say try, catch, exception E. That means something went wrong. Maybe we had a database connection error or something like that. I hate to leave a catch block blank, but I might just do that for the moment. So we'll say to do add logging. Nonetheless, you see that we now have the point where our controller knows what the specimen service is, and our controller can connect to that specimen service. And we can do this with the other endpoints that we have mapped here as well. As a matter of fact, I'm going to add a little bit of new behavior to fetch all specimens. I'm going to say specimen service, and then fetch all. That method does not exist yet, so I will let IntelliJ do a bit of work for me. You see it creates this fetch all. And then we see one related problem, which is probably talking about the implementation. And sure enough it is, so I'm going to say implement methods and fetch all. And that's just as well because this is exactly where I wanted to be in the implementation. Now we see we have the @component annotation. We know that we can use the @service annotation here as well, which is just like @component. It's just marking that we are in a service class. So clean up our imports a little bit, and there we go. The next thing that we need is our specimen DAO. So we can continue to iterate here, and we can say auto-wired. Note that we are from the controller to the specimen to the DAO. We're using this auto-wired annotation. Now, if we take a look at the specimen DAO, we don't have any class that implements the specimen DAO yet. So why don't we make that? But first I want to finish out the logic that I was creating in this fetch all function. So fetch all, we're likely going to go back down to the DAO and we're going to fetch all there as well. So I'll simply say return specimen DAO.fetch all. Now realize now that that shouldn't be void. We should actually be returning a list of specimen objects. So I'm going to have a couple changes I'm going to need to make here. No problem. We'll fix it just like that. Essentially, I'm fixing the interface method signature to match this method signature, and then I'm going to add this import here. Let's go back and take a look at our specimen service, and you see that now, sure enough, it is returning a list. We'll go ahead and take care of that, and we'll take care of the related issues as well. So it tells us, okay, we have a usage, and here's our usage. Well, it's telling us here, okay, specimen DAO, that exists, but this fetch all method does not exist. Once again, just want to give you a little point on where we are because I know I'm bouncing across between files and want to level set a little bit. So we are here in the specimen service stub. We've added a new method here. We've also added a new method to the specimen service. And now what we are trying to do is to connect up to the specimen DAO. The problem is we don't yet have a class that implements the specimen DAO. So we've created a couple methods in it. We need to create the implementing class as well. And then we need to annotate the implementing class with the @repository annotation. So let's continue. First of all, specimen DAO fetch all, what's it telling me here? Probably that this function, this method does not exist in specimen DAO. And if I take a look, sure enough, it does not. Let's see if the IDE can help us out here. And sure enough, it can. Create method fetch all in iSpecimen DAO and enter. And number 1, we get our method here. Number 2, the red lines go away in our specimen service stub. Okay, deep breath. So we need to make one more class. The class we need to make is the Specimen Dao stub that will implement the Specimen Dao interface. We don't yet want to make the actual implementation because at this point we don't know how we're going to persist. So let's go into our DAO class. or DAO package rather. I'm going to right click and say Java class, and we'll call this one Specimen Dao Stub. Go ahead and add it, and then we'll say implements iSpecimen DAO. Now, part of implementing the Specimen DAO, part of implementing an interface in general, is that interface is essentially a contract. It only needs to be a list of methods. Because remember, variable type tells us what methods we're allowed to call. And that's all a variable type does. Since an interface can be a variable type but not an object type, it only really needs to be a list of methods. Now the object type is going to be a class that implements that interface. That list of methods is a contract, and it means anyone who implements this interface is under contract to either implement these methods or have a further subclass that will implement these methods. So we see here we have a red line. I'm going to Alt-Enter, and I'm going to say implement methods, and there we go. Now, remember this is a stub because we don't know what our actual persistence mechanism is going to be, but that's okay because we have two operations here that are really easy to take care of. One is a save, the other is a fetch. All we really need here is a list or an array list that's going to store the items that are saved and then retrieve them in the fetch all. Very simple. So we'll say list specimen all specimens equals new array list specimen. And if you're curious, why do we put list on one side and array list on the other? Well, guess what? List is an interface and array list is a class that implements that interface, just like iSpecimen DAO and Specimen Dao Stub. Okay, from here, on the specimen save, we're simply going to say all specimens dot add specimen, which is the parameter that's passed into this method, and then simply return specimen. Easy enough. For fetch all, guess what? We simply return all specimens. Now let's add our annotations at repository. And remember, that's just one part of the train. That's one boxcar that we want to attach to another. So to attach to the other boxcar, we need to come up here and have auto wired on the variable declaration in the service class. Looks like that's already there. So you see the service class is going to reach down and grab the Specimen Dao Stub. It's going to instantiate it, and it's going to save it into the variable Specimen Dao. And that variable Specimen Dao is used by most of the methods of this class. Now I want to show a round trip where we can save specimens and then retrieve them as well. So I'm going to clean up this fetch all method just a little bit and use a couple shortcuts here. First of all, if we use the annotation response body, it's going to take whatever the return type is and marshal it to JSON. So it saves us from having to do that. The only trick is then we need to change the return type as well. So we'll change it to list specimen, which hopefully sounds familiar because it's what we get back from this fetch all call. So we'll say return specimen service fetch all. A little bit of tidying up here. And we'll get the Java util list. So a little less typing. What we're doing is we're just saying, get me all the specimens, return them, and then via response body, automatically marshal them into JSON. Now, one other thing we want to do is step through this in the debugger. So note that I've snapped a breakpoint on the list, and I've also snapped a breakpoint down on the create specimen. In other words, the get mapping that returns all, we have a breakpoint there, and the post mapping that creates one, we have a breakpoint there. Now I paused the video for a moment and I added a few specimens so that we would have a few in our collection. Let's go ahead and do one together. Note that I'm using the post HTTP action, and post typically means create new, and you'll also remember that we have post mapped with our post mapping to this create specimen method. So post, it's going to accept some JSON, which I have here, and it's going to automatically marshal that JSON into a specimen because we're using the request body annotation. So everything looks good. I go ahead and I hit send. We notice it waits for a moment, and at the same time IntelliJ IDEA lights up in orange, and we get a blue bar where we set that breakpoint. So let's go ahead and follow it through. As I'm typing here, just pay attention to what you see in the tab because we're going to be iterating through a lot of these classes from our class diagram. Now, one word of warning. There are many different IDEs, and none of them actually standardize on the debug keystrokes, so it always pays to just refresh what they are. In IntelliJ, you'll find them here at the bottom in the debugger console. So step over is F8, step into is F7. What's the difference? Step over means execute this line and then go to the next line. Easy enough. Step into means if this line has a method call, let's step into that method call and see how it runs. I'll emphasize many times over that in our field, you're going to spend more time figuring out someone else's code than writing something from scratch. And therefore, it's more important to be a good debugger than it is to be a good programmer. Also, by far, the debugger is the easiest way to learn something. If you're struggling with learning programming, learn the debugger. It will make your educational journey much easier. Many times when I interview a candidate, I'll ask, hey, what's your approach to starting new at a company? There's all the source code that was written before you were here. Nobody's around to help you. How do you learn it? And a lot of people have a lot of different approaches. For me, when I'm interviewing, if I hear the person say, I'll set a breakpoint, I'll walk through the debugger, that's an answer that's going to make me very happy, because this is someone who's self-sufficient and can learn and knows how to learn by using the debugger. So anyway, watch what happens. I'm going to choose F8. We go from line 73 to the next executable line, which is line 75. Now, if I mouse over specimen, and you can also see it on the right, notice plant ID 85, specimen ID 1004, so on and so forth. This all looks very familiar. And it should, because it's what we put in Postman here. What you see happened is it took this request body annotation and it was able to marshal that JSON into our specimen object successfully. Okay, so now look what we're doing. We're on specimen service.save, but we're still in our controller. So what's going to happen if I choose F7 now? It's going to do a step into, which means it's going to let us take a look at the save method. So F7, and take a look. Where are we? Specimen service stub. Sure enough, we're here. And what are we doing here? We're on specimen dao.save, which means if I press F7 now, where are we going to go? We're going to go to the DAO. So you see we've traversed from UI controller to specimen service to specimen DAO in the DAO package. And now what's the DAO going to do with it? Simply going to add it to a list and then return, 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 and F9 means continue. Thank you so much. We're all finished debugging. So we come back and we look at Postman and everything's happy. Now let's try our get. And with get, the endpoint's going to be the same. We're not going to need a body, but let's go ahead and hit send. And remember that get that is attached to the specimen endpoint without an ID is going to invoke a fetch all. So here you see specimen endpoint, you see get mapping, and you see, sure enough, fetch all specimens. Let's watch it work. I hit send. Notice IntelliJ lights up orange again, and let's take a look. We're in the controller, and you can follow along with me here again. Notice that I'm on the fetch all call for specimen service, so I press F7. That takes me into specimen service stub. That wants to call down to our specimen DAO fetch all. I press F7, and take a look what it's going to do. It's going to return all specimens. Let's do a quick mouse over of that, and we'll see that there are the specimens that I created with the video on pause, and then this specimen that we created together for a total of 4. So I choose F9, and then I bring back Postman, and take a look at what we got. We got a JSON array of 4 specimen objects. So in this video, we've seen the auto-wired annotation and also the component, service, and repository annotation, and we see how those have worked together to instantiate an object, as we see here, and assign it to a variable, but without needing the assignment operator and without needing the new plant DAO stub hard-coded. And I emphasize it doesn't need to be hard-coded, and that's one of the values of Spring, is that you can write a program, and you can write it to contracts like we have with our interface here, and then later you can decide what object is going to fulfill that contract. In other words, what object of what class is going to fulfill that contract. Now, the value of delaying that decision until later is very valuable. Maybe you'd make that decision at runtime so that this application can actually have different behavior plugged into it. Or Maybe you're in the business of writing software and you simply write these interface contracts and then you let your customer decide how to implement that contract so that they can use your framework while at the same time plugging in their own logic and using customizations while still using your framework. So I hope this video has been helpful and I look forward to reading your comments. Thank you.